Hi, this is Mr. Manley. In this video, I want to look at graphing inverse trig functions. All right. So we're going to begin with the parent functions here. So the parent function for sine, inverse sine of x, and that is going from -1 to 1 and from pi over 2 to negative pi over 2. Can you think about how that makes sense, that the sine inverse of sine x, its inverse switches the x and the y, right? So on a sine function, these values would be on the x-axis, right? Now they're on the y-axis. On a sine function, these values would be on the y-axis. Now they're on the x-axis. And then the shape of this goes up like that and down like that. And that's the inverse of this shape, right? So if I looked at the graph of sine x, that's the inverse. It's a reflection through the line y equals x. Okay, so let's look at the other one. We have y equals inverse cosine x. And if you remember how inverse cosine works, it's the angle between 0 and pi. So cosine is going to go up to pi. So notice sine is the angle, the inverse sine is the angle that is between negative pi over 2 and pi over 2. For cosine, it's the angle that's between 0 and pi. So we're just going to go from here to here. We're still going to go from -1 to 1. Okay. All right. Which of these, so when I'm at pi, the cosine of pi is 1, right? So the inverse cosine of 1 is pi. And then the inverse cosine, am I saying that right? No, I'm saying that, I said that wrong. Let's just look at a table. Shouldn't have to use this every time, but so if I go x, y, and then I go x is 1, when x is 1, that's y of 1, which is the inverse cosine of 1. And what angle has a cosine value of 1? So that means the x coordinate of 1. And on a unit circle over here at 1, 0 with an angle of 0. So my y value is 0. So I put that point in the wrong place. Should be 1, 0. Okay. And then -1, if I do a -1, the inverse cosine of -1 is pi. So it's going to be this point over here. All right. And then I need to do a cosine curve, because that's the inverse of this. Well, where would it be? Maybe something like that. But that's not great. The scale makes it difficult. So that's the parent function for inverse cosine. All right, so you want to get those points, those end points there, and then the curve goes through there. It's a reflection of the cosine curve. All right, and then finally, let's look at the parent function for inverse tangent. All right, right? So if you remember tangent, that has vertical asymptotes, right? And then through the reflection to the inverse, we're going to have horizontal asymptotes instead of vertical asymptotes. And they're going to go from negative pi over 2 to pi over 2. And the tangent curve is going to go up towards pi over 2 that way and down towards negative pi over 2 that way. And those are the three parent functions. So let's look at if we were going to be asked to graph something that is a variation on that. We'll start off with inverse tangent of x minus 2. And we will do these if you know what I want from graphing a trigonometric function. I want this 5-point method. But for inverse functions, we will do it as a transformation. So if I think about the negative pi over 2, positive pi over 2, negative pi over 2, and I have the asymptote like that, and then the tangent function would go like that, right? So it would go there. And so the only difference is this is shifted, right? So that's from early days of a pre-calculus course, a transformation. And what does the minus 2 do? It shifts its 2 to the right. So I'm just going to take and give myself a 1, 2 intercept, and then I'm going to go up to pi over 2 and go down to negative pi over 2, and that's it. That's the transformation, and that's all you would need to show. Let's say I did an inverse sine, and let's call it x over 3. We're just going to do this as a transformation now. So let's look at our original. Our original was going to be from negative 1 to 1, and then from pi over 2 to negative pi over 2. And we have these points here, right? This point and this point, and it comes down like that. So what does this 3 do? That is a horizontal transformation, right? And it is going to horizontally stretch this. This is pretty trivial and obvious, but I just want to pull out the 1/3. So this is telling me that this graph is going to be 3 times as wide. That's what that does. So I'll just go 1, 2, 3. 1, 2, 3. Put my point there. And I'll put my point out there. Let's erase the parent function. And if you wanted to check this, go x, y. And if I let x be 3, what am I going to have? I'm going to have the inverse sine of 1. And what's the inverse sine of 1? What angle has a sine value of 1? Well, it's pi over 2. So 1, 2, 3. and then pi over 2. Go up to pi over 2. This is equal to pi over 2. If you're having trouble following at this moment, just enter that in the calculator. But then you do need to think about how you can find that without a calculator. Okay? So let's just look at one more. We'll look with cosine, inverse cosine. So y equals inverse cosine. Now let's do a 2x here. So we're going to look at where's the parent function. Going from 1 to -1, going up to pi, and it was going to look like this, right? Like that. That's the parent function. What does this 2 do? Cuts it in half, right? So I'm going to go half, -1/2, like that. And I'll erase the parent function there. And that's it. So just some nice little transformations once you know the parent functions. And notice the couple of times that I just did a check. Just want to go, well, all right, let me look at what the points would be. And then that'll give you an opportunity to work on your evaluation of these inverse trig functions as well. All right, so that's graphing, and we'll just do those 3. Won't get into inverse cosecant or inverse secant. And we'll be able to graph those, and that will be enough.